I'm going to show you how to write into a vertex form using completing the square method. But this time, these ones are challenging ones because the leading coefficient is not 1, it's 2. So it gets a little bit different, okay? But step number 1 is the same. We're going to move the constant to the other side, okay? So I will have f of x minus 9, and on the other side I have 2x squared minus 8x, okay? So step number 1 is the same. Move that useless constant to the other side while we do the perfect square work on the right side, okay? All right, this is what you're gonna have to do. Keep the left side the same, but you always divide by the number in front of x squared. Divide by the leading coefficient, okay? I'm gonna divide both of these by 2. Well, I shouldn't say just divide. I will factor out 2, okay? I'll divide these by 2. I write down 2 outside, and what is left inside? I have x squared minus 4x left inside. So always divide by the leading coefficient. For example, if I had 5 there, I would have divided both of these by 5. It's not a GCF. It's not even a common factor, okay? It's nothing like that. We're dividing by the leading coefficient, and we are doing that to make the leading coefficient 1, okay? So sometimes, the numbers worked out okay this time, but sometimes your b value, this will turn into a fraction or something else, but then what you have to do is just always divide by that leading coefficient, okay? Because what we want to do is have 1 x squared, okay? After that is very similar, okay? What I'm gonna have to do is I'm gonna have to figure out what we need to add to both sides, okay? So the thing is, what I'm adding to the left-hand side and what I'm adding to the right-hand side will be slightly different, okay? Now, what should I add in here? Remember, it's always half of the middle number, b squared, right? So if you take half of negative 4, take half of negative 4, that is negative 2. But if you square negative 2, you get positive 4. So the number that I'm adding to the right-hand side is actually 4, okay? So I do plus 4 inside. But here's the thing though. Am I really adding 4 to the right-hand side? It's not really, because look, I'm actually multiplying 2 times 4. I'm adding 8 to the right-hand side, okay? So on the left-hand side, to be fair, I should not just add 4, I should really add 8. See, that's what makes this type of problem difficult, because very often people ignore this 2 that we factored out. So they would add 4 to both sides, but that's not fair because the right-hand side actually got added by 8. That's why we're adding 8 on the left side, okay? All right, after that point on, it's really the same. I need to combine these two terms. So I will get f of x minus 1 equals 2 times. Let's go ahead and factor that. Let's go ahead and factor that perfect square trinomial. Give me 1 second. I want to make this a little bit smaller. If I factor that perfect square trinomial, I will get x minus 2 squared, right? Because negative 2 times negative 2 is positive 4. Negative 2 times negative 2 plus negative 2 is negative 4. So that's how you factor that perfect square trinomial. And the very last step that we have left to do is just add 1 to both sides so that f of x is all by itself again. F of x equals 2 times x minus 2 squared plus 1. All right, I will zoom out to see what we just got matches what we got using the vertex formula method earlier. Look, they are the same. So it's your choice if you like the vertex formula method, which I like. I like this one better for these cases. But completing the square looked a little bit different, right? A little bit different when that leading coefficient wasn't 1. And the trick was to divide both sides by, divide by that number, that leading coefficient, to make a 1. And that you're going to have to add a different number to both sides when you are completing the square. I don't know, this can be challenging. But let me do one more example for you, okay? Just one more. But worst case scenario, if this method is not really making sense, of course you and I will talk about it, but I want you to go with the vertex formula method for cases where a is bigger than 1. All right, but one more. I'll go ahead and do this one. Let me copy this, paste this over here. All right, I'm ready to start. Let's move that negative 56 to the right side for now. It's going to come back later as something else. So I will have f of x plus 56 equals 7x squared minus 14x. Left side just waits. But guess what I'm going to do to the right-hand side? I'm going to have to divide by this a, so that 7x squared becomes 1x squared. I'm going to divide both of these by 7. That 7 is outside the parenthesis, but inside the parenthesis now I have x squared minus 2x. Okay? Alrighty. I'm going to go ahead and copy this line down, because what I'm about to do is I'm going to add a number to both sides. Right-hand side, we're going to add a number inside the parenthesis. All right, so what do we have to add? We have to add, take half of negative 2 and square it. Okay, what's that going to be? Half of negative 2 is negative 1. Negative 1 squared is 1. So I'm going to add 1 in that parenthesis. But technically, what am I adding to the right-hand side? I'm not just adding 1 to the right-hand side, right? I'm actually adding 7. 7 times 1, when you distribute it, you will get a plus 7 in this position. So I should not add 1 here. I should add 7 on the right side. That's why the numbers that we are adding looks a little bit different, okay? Okay. It's time for us to simplify. Time for us to simplify this. So if you combine the numbers on the left side, 56 plus 7, 63. Uh-oh. Plus 63, right? And what we have to do is we have to factor the right-hand side. Put the 7 outside. But this trinomial right here, that is a perfect square trinomial. Okay? Which we can factor into x minus 1 squared. Let's see why. Because negative 1 times negative 1 is positive 1. That matches that. And negative 1 plus negative 1 is negative 2. And that matches this middle term. So we did factor it perfectly. And the very last step, all we need to do is move that plus 3 back, right? Move this back by subtracting 63. So our final answer is f of x equals 7 times x minus 1 squared minus 63. Looks a little odd, so I'm going to make sure to compare this with another answer that I got using a different method. I did it twice using different methods, so if the answers are matching, I'm pretty sure we got these right. And look at that. The previous method that we used, the vertex formula method, we got the same exact answer. So completing the square method is a little more difficult when the leading coefficient is not equal to 1. You can still do it, right? It's very nice. But I would suggest that you work with vertex formula because I don't know, I think that's easier. Okay, but that's enough for rewriting a quadratic function to find its vertex. I guess the vertex method formula is kind of working backward, right? Instead of finding the vertex from the equation, we found the vertex and wrote the equation. Well, I said, why not? You know, it's cool to see two different methods. But that's enough for me. That's enough of me. I will come back later to talk about quadratic word problems in another video.